Everybody. So we are going to discuss about the applications of RL circuit, RLRC, RLC circuits. This is the application of RC circuit. Okay. This is the application of RC circuit. Okay, photo flash unit. Okay, this is the application of RC circuit. Okay, digital camera flashlight utilizes a RC circuit to create a short duration high current impulse. Sorry, high current pulse. Okay, to energize the flashlight. Okay, in order to produce flashlight, okay, this camera utilizes RC circuit. Okay, RC circuit will be present inside of this camera in order to produce flashlight. Okay, let us see how will it produce. Okay, so initially this will be the circuit. Okay, initially you're going to have the circuit like this. Okay, here the switch is in position 1. Initially the switch is in position 1. Okay, let R1 is the resistance of R1 is the resistance of this resistor. Okay, this is somewhat large value. Okay, here we apply high voltage. Okay, high voltage capacitance. Okay, here when the switch is in position 1, this capacitor gets charged with applied voltage. Okay, then finally that is we can say VC of 0. Initial voltage is equal to what? Vs. It gets charged with applied voltage, right? Okay. Now let me close the switch. Sorry, let me move the switch in position 2. Then this is the circuit. You're going to have source free RC circuit. You're going to have source free RC circuit. Initially, we are having RC circuit. We are having RC circuit with source. Okay. The switch is in position 1. This will be the circuit. When the switch is in position 1, this will be the circuit. Okay. Let this capacitor get charged with applied voltage. Then VC of 0 is equal to Vs. Okay. The voltage across this capacitor is now Vs. The switch is now moved to position 2. Now move to position 2. Here this is R2. Here R2 is the resistance of lamp, photo lamp. This is the resistance of photo lamp. Okay. Here this is the resistance of photo lamp. Okay. So you're going to have voltage across capacitor like this. Till this point, charging of the capacitor is taking place. Okay, that is when the switch is in position 1. Okay, you're going to have the circuit like this, right? Okay, R1 and capacitor. Okay, in case of RC circuit, voltage across the capacitor rises exponentially and reaches final value. Okay, here T is equal to, you know, right? What is the time constant? Time constant tau is equal to RC, R1 into C here. Okay. What is the time taken to charge capacitor? T charge is equal to what is the 5 time constants, right? 5 times of time constant, right? Okay, which is equal to 5 into R1C, which is equal to 5 into R1C. Okay, here R1 is large value. Okay, if R1 is more means, okay, tau will be more. If time constant is more means slower will be the response. Slower will be the response. Okay, so slowly the capacitor will get charged with applied voltage. Finally, voltage across the capacitor reaches its applied voltage. Okay, so it takes more time to charge capacitor because R1 is more. Okay, now when the switch is moved to position 2, this will be the circuit. Okay, this will be the circuit. Here R2 is the resistance of the photolamp. Resistance of the photolamp. Okay, so what will be tau 2? Tau 2 is equal to R2C. Tau 2 is equal to R2C. Okay, now what is the time taken by the capacitor to get discharged? T discharge is equal to 5 times of time constant. 5 times of time constant. Get out. Okay, here R2 is very low value. R2 is very low value, then tau 2 would be very low value. Okay, if tau 2 is very low value means response will be faster. You're going to have faster response. Okay, faster will be the response. Okay, lower is the time constant, faster will be the response. Okay, so while charging, the current will be like this. While discharging, more amount of current will be discharging through R2 because R2 is very low value. R2 is very low value. Okay, so capacitor voltage showing slow charge and fast discharge. Okay, low charging current I1 is equal to Vs by R1. Whereas coming to I2 discharging current, which is equal to Vs by R2. Vs by R2. Okay, we know, right? I is equal to C dV by dt. This RC circuit utilizes that property. Okay, you know the property of capacitor, right? What is the property of the capacitor? Capacitor opposes sudden change in voltage. Okay, voltage across capacitor cannot change instantaneously. Means within zero time. See, normally let Vs is the applied voltage. Initially, let it get charged with Vs. Okay, the time taken. So here, Vs becomes 0 by taking less time. Okay, within short period of time, here change in voltage across capacitor from Vs to 0. From Vs to 0. Okay, means this is very small value. Change in time is very small value. Then current will be more. Current will be more. Okay, then you're going to get flash. Okay, here the current pulse is very more. Okay, because of low resistance. Okay, relay circuit. In relay circuit we use RL circuit. Okay, so here when you close the switch, okay, magnetic field will be developed in this coil, so that you can close the switch S2. Okay, likewise by charging this inductive coil, we can close or open the switch. Okay, automobile ignition. This is the application of RL circuit only. RL circuit. This is the application of RL circuit. Okay. Actually, in order to run automobile, we have to ignite the fuel. We have to ignite the fuel, right? We have to ignite the fuel. In order to run automobile, we have to ignite the fuel, right? Okay. So, in order to ignite the fuel, we have to produce spark. Okay, actually by using this RL circuit, okay, here you have series RL circuit. Okay, by using series RL circuit, you are going to produce spark in order to ignite fuel. In order to ignite fuel, so that you can run automobile, right? Okay, so this is achieved by means of spark plug. Spark plug. Okay, which essentially consists of a pair of electrodes separated by an air gap. Okay, you can see here. Okay, here you can see two electrodes, two electrodes separated by an air gap, separated by an air gap. Okay, two electrodes separated by an air gap, right? Okay, you can see here. Okay, this is spark plug. Okay, it is having one pair of electrodes. Okay, these two are separated by an air gap. Okay, so here what we do is first you close the switch. Okay, let me close the switch. Okay, if you close the switch, current will be flowing to this. Okay, you're going to have the response like this. Current will be increasing exponentially. Exponentially rises and reaches final value. At this instant, inductor acts as short circuit. Okay, then what will be steady state current? I of infinity is equal to what? I of infinity is equal to Vs by R. I of infinity is equal to Vs by R. Okay, normally the voltage which is applied to this is 12 volts. Okay, in car we use 12 volts battery in order to produce spark, so that you can ignite the fuel. You can ignite the fuel. Okay, just because of using 12 volts, you can ignite the fuel by producing spark. Okay, so this is 12 volts. Let me use some 4 ohms. Okay, so what is the steady state current? 3 amps. Steady state current 3 amps. Okay, now what you do is suddenly you open the switch. Suddenly you open the switch. Suddenly opening the switch means you are making current from 3 amps to 0 amps. You are making current from 3 amps to 0 amps within you take some 10 microseconds. Within 10 microseconds, okay, you are making current from 3 amps to 0 amps. You are changing current from 3 amps to 0 amps by taking 10 microseconds. Then you know, right? V is equal to L di by dt. L di by dt. Okay, which is equal to, you take some value L, you take some value some 2 Henry. Okay, 2 into what is the change in current? 3 by what is change in time? 0 to 10 microseconds. Mean 10 microseconds. 10 into 10 power minus 6. Okay, you take L is equal to 10 milliseconds. 10 milliseconds. Okay, then you're going to get 6 into 10 to the power of 3, I think. 3 or 4. 4, right? Okay. Almost how much? 60,000 volts. Almost 60,000 volts will be produced between the terminals of the inductor. Okay. That is, see, first of all, what you are doing is you are closing the switch. First, you close the switch. Okay. When you close the switch, it gets charged with final value. Okay, then final value would be 3 amps. Okay, suddenly you open the switch. When you open the switch, suddenly means you are making current 3 amps to 0 amps. Okay, by taking this much time. Okay, V is equal to L di by dt means change in current is equal to 3 amps by changing time would be to take 1 microsecond or 10 microseconds. Okay, if you take 1 microsecond, then you're going to produce 6,000 volts. 6,000 volts across inductor. Okay, that 6,000 volts, which is applied across spark plug. Okay, when this much amount of voltage is applied across spark plug, then spark will be produced. Okay, spark will be produced. Okay, this spark is used to ignite the oil, ignite the fuel. This spark is used to ignite the fuel. Okay, the ability of inductors to oppose rapid change in current makes them useful for arc or spark generation. Okay. Inductor opposes sudden change in current, right? Okay, that's why if you want to change current from 3 amps to 0 amps, okay, by taking very less time, then large amount of voltage will be produced across inductor terminals, across inductor. Okay, that voltage is applied across spark plug, so that spark will be produced. Okay, you can have a parallel LC circuit, line trap. Okay, in substation we will have this kind of arrangement. We'll have this line trap circuit. Okay, in substation we have surge resistor also. We will be having surge resistor. We'll be having line trap. Okay, line trap is a parallel LC circuit. Okay, electric fan circuit. Okay, electric fan circuit is RLC circuit. Okay, this is application of RLC circuit. Okay, here you're going to have winding. Winding means which is having resistance as well as inductance. Okay, you're going to have two capacitors. Okay, one is used to make induction motor self-starting, and the other capacitor is used to improve power factor. Okay. Tube like circuit. RLC circuit is involved in this tube light. Okay. RL choke coil. Okay. Normally you're going to have tube light like this. Coming to the working of tube light. Okay, you're going to have two electrodes, two filaments made up of tungsten. Two filaments. Okay, made up of tungsten. The gas which is present inside of tube is inert gas. Normally argon gas. Argon gas is present inside of this tube, right? Okay, so supply voltage is given, 230 volts is given. Okay, here you're going to have choke coil. Choke coil will be connected like this. This is the choke coil. Okay. Here you're going to have starter. Starter. Okay, in starter you have neon lamp. You're going to have neon lamp. Okay, this is lamp. You're going to have lamp like this. Lamp capacitor is connected across this lamp. Okay, so here you're going to have neon lamp. You're going to have neon lamp. Okay. When you apply voltage across this tube, okay, this filament gets heated up. as well as this also gets heated up. Okay. With the help of applied voltage, these two will get heated up. Okay. So here, instead of this tube, you're going to have a little bit of mercury. A little bit of mercury is Hg, right? A little bit of mercury is present inside of this tube. Okay. When you heat up these two filaments, okay, argon gas is present inside of this tube, right? Okay. So this gas is composed of atoms. Okay. Gaseous atoms, we're going to have different orbits. Take one atom. Okay, this is nucleus. Okay, electrons. And atoms, this is an atom, right? Gaseous atom. Okay, atom. And atoms, electrons have different levels of energy. And atoms, electrons have different levels of energy. Electrons of different energy levels occupy different orbitals. Generally speaking, electrons with greater energy move in orbitals farther away from the nucleus. Farther away from the nucleus means the electrons which are present in the outer orbitals are having more energy. The electrons which are present near to this nucleus in this orbital, okay, these electrons are having less energy. Okay, these electrons are having less energy. The electrons which are moving in the outer orbital having more energy. Okay, so here the moment these two filaments get heated up, okay, that heat energy, okay, because of that heat energy, these electrons are boosted to higher energy levels. Okay, so let this is first orbital, second orbital, this is third orbital. Okay, let this electron is subjected to heat. When this electron is the electron which is present in first orbital is subjected to heat, then it moves from first orbital to, you take some fifth orbital. Let it move from first orbital to fifth orbital because of heat energy. Okay, that is, an electron may be temporarily boosted to a higher orbital. Temporarily, this electron is boosted to a higher orbital. Okay, this electron only holds this position for a tiny fraction of second. Okay, the electron which is moving from first orbital to fifth orbital, this electron holds only for a tiny fraction of second. Holds this position. Okay, this electron stays in this orbital only for a fraction of second. Okay, after that it will come back to its virgin orbital. Okay, it will come back to its virgin orbital. When it is coming back to its virgin orbital, this electron releases energy in the form of photons. That electron releases energy in the form of photons. In the form of photons. Okay. Likewise, some electrons are moving from lower orbital to higher orbital, okay, because of heat energy. Okay, first because of applied voltage, these two filaments get heated up. When they get heated up, heat energy will be produced. Okay, because of that heat energy, the electrons which are present in the gaseous atoms will get excited and move to higher orbitals because of heat energy. Okay, and these electrons hold their positions for a tiny fraction of seconds. Again, they'll come back to their original orbitals. When they come back to their original orbitals, they'll release energy. They release energy in the form of photons. Okay, so when electrons coming back from higher orbital to lower orbital, they'll release energy in the form of photons. In the form of photons. Okay, the electrons, the energy which is, the photons which is produced by this electrons are in ultraviolet range. Ultraviolet wavelength range. Wavelength range. Okay. Electrons release energy in the form of photons. These photons are the photons which are released by electrons are ultraviolet wavelength range. Okay, our eyes don't register ultraviolet photons. Okay, because wavelength is more. Okay, wavelength is more, right? Okay, so our eyes don't register ultraviolet photons. Okay, so in order to convert this ultraviolet wavelength range photons into visible spectrum, we use phosphor coating. Okay, so here the tube contains a little bit of mercury, right? Okay, and an inert gas. Okay, the tube also contains a phosphor powder, okay, coated along the inside of the glass. This phosphor coating is used to convert ultraviolet photons into visible spectrum. Okay, so here coming to the role of this mercury. Okay, because of this heat energy, this is in liquid form, right? Okay, because of this heat energy, mercury liquid, okay, this liquid changes into gas. Okay, this liquid changes into gas. Okay, when it is changing from liquid to gas, okay, this mercury changes from liquid state to gas state because of heat energy. This mercury changes from liquid state to gas state. Okay, again electrons are present in this gaseous molecules, right? In this gaseous molecules, again electrons are present. Okay, electrons in argon gas, electrons in gaseous mercury, they'll collide each other. Okay, these electrons will collide electrons of gaseous mercury. Okay, when they collide each other, again these electrons are boosted to higher energy levels. Means they are moved to higher orbitals. These electrons are moved to higher orbitals. When they are moved to higher orbitals, okay, again they will come back to their virginal position. Again they will come back to their virginal orbitals. When they come back to their virginal orbitals, again these electrons will release energy in the form of photons. In the form of photons. Okay. Now coming to the role of starter. This is starter, right? Okay. After all, this is gas. Gas is present instead of the tube. After all, this is gas. No conducting medium between these two electrodes. Okay. Here the medium which is present between these two electrodes is argon gas. Argon gas. Okay. So coming to the role of starter. Starter consisting of neon lamp and capacitor. Okay. Neon lamp. This is neon lamp. Okay. So when the voltage is applied to the tube light, okay, then because of the applied voltage, an electric arc will be produced. Wait for that. Okay, right. Okay, this is neon lamp, right? Okay. Neon lamp. Okay, neon gas is present inside a lamp. Okay. Here we have two electrodes. Okay, among these two electrodes, one of them is bimetallic strip. This is bimetallic strip. One second. Among two electrodes, one of them is bimetallic strip. Okay. This is bimetallic strip. Okay. Because of the applied voltage, an electric arc will be produced between these two electrodes. An electric arc will be developed between these two electrodes. Between these two electrodes. Sorry. electrodes. Because of the applied voltage, an electric arc is produced between these two electrodes. Okay. Initial current causes electrical arc between electrodes, which ionizes gas present inside of this neon lamp. Okay, this heat ionizes this gas. Okay, because the spark is produced, right? Spark will be produced because of applied voltage. Because of applied voltage, because of applied voltage, okay, spark is produced. Spark is produced between these two electrodes. These two electrodes. Okay, that heat is used to ionize the gas present inside of this neon lamp. Neon lamp. Okay, so because of this heat, this bulb glows. Neon bulb glows. Okay. When this bulb is glowing means heat will be produced. Heat will be produced. Okay. Because of heat produced by this bulb. Okay. Because of heat produced by this bulb, bends this bimetallic strip. Bends this bimetallic strip. Okay. Initially, because of initial current. Okay. Sorry. Okay. Here we have two electrodes, right? Two electrodes. Okay. Because of initial current, arc will be produced. Okay, arc will be produced between these two. Okay, because of this heat ionizes neon gas, so that neon lamp glows. Neon lamp glows. When the bulb is glowing means heat energy will be produced. Okay, heat energy produced by bulb bends this bimetallic strip. Bends this bimetallic strip. Okay, bends this bimetallic strip. Okay, so that this bimetallic strip will make contact with other electrode. This bimetallic strip make contact with other electrode. Okay. When it is making contact with other electrode, which turns off the starter light, which turns off the neon gas lamp light. Okay. See, the bulb glows if there is spark between two electrodes. The spark is used to ionize gas. Okay, because of heat produced by the lamp. Okay, so bulb glows. Okay, because of heat produced by this lamp. Okay, this bimetallic strip bends towards other contact. Okay, bends towards other contact, and this bimetallic strip makes contact with other electrode. Okay, so current will be flowing in this direction. Okay. When it is making in contact with this other electrode, now the circuit is closed. When the circuit is closed, no heat will be produced. Earlier, heat was produced because of spark produced between two electrodes. Now, when these two contacts are closed together, no heat is produced. When no heat is produced means, okay, this bulb gets turned off. This neon gas bulb gets turned off. When this bulb gets turned off means, okay, no heat energy will be produced by that bulb. Okay, when no heat energy is produced by that bulb means, 12 means that this bimetallic strip bends away from this contact. Okay, bends away from this contact because it cools down. Okay, this bimetallic strip gets cooled down. Okay, so that it moves away from this electrode. Okay, so here opening switch suddenly. Okay, so initially, because of initial current, electric arc will be produced between electrodes, which ionizes gas. Okay, the heat from the light bends bimetallic strip, closing the switch, which turns off the starter light. Okay, so the bimetallic strip cools and returns to its original position. Current flows through the ionized gas in the tube. Okay, current flows through the ionized gas in the tube. Okay, so when you open the switch suddenly, okay, V is equal to L di by dt, right? Okay, within fraction of seconds, you are changing current from one level to another level. Changing current from one level to another level within fraction of seconds. Okay, you're going to produce large amount of voltage, around 2500 volts or 2000 volts. Okay, so you are opening this inductor for a short period of time. Okay, see, when these two are in contact, okay, current will be flowing through the circuit. So magnetic field will be developed in this choke coil. Okay, when you open the switch suddenly, okay, due to sudden collapsing of magnetic field, okay, large amount of voltage will be produced across this inductor. Okay, generally the voltage would be around 200, 2000 or 2500 volts. Okay, this 2500 volts plus applied voltage 230 volts. Okay, around 3000 volts. Will be applied between two electrodes. Applied between two electrodes. Okay, applied between two electrodes means that 3000 volts will produce an electric arc, that will establish an electric arc between two electrodes. Okay, because you are applying around 3000 volts. Between two electrodes. Okay, this 3000 volts will establish an electric arc. Once an electric arc is established between these two filaments, then current will not flow through starter. Okay, then current will be flowing through this path. Okay, applied voltage, so coil and filament. Okay, and starter, right? Okay, then current will be flowing through this path. Okay, current will not flow through the starter. Okay. Initially, a starter is consisting of neon lamp and capacitor. Capacitor is connected across this neon lamp. Okay, so here neon lamp is having two electrodes. This lamp is having two electrodes. Okay, among these two electrodes, one of them is bimetallic strip. Okay, so because of applied voltage, initially an electric arc is produced between these two electrodes. An electric arc is produced between these two electrodes. Okay, so that heat will be produced. Heat will be produced. This heat ionizes the gas which is present inside of this neon lamp. This is neon lamp. This is neon lamp. Okay, this ionizes gas which is present in neon lamp. Okay, so that this bulb glows. This bulb glows. This bulb glows now because of this heat energy. Right? When the bulb is glowing, okay, this because of this heat produced by this bulb, okay, bends this bimetallic strip, okay, this bimetallic strip bends towards other electrode, okay, this bimetallic strip bends towards other electrode because of heat energy produced by the lamp. Okay, when this bimetallic strip is bending towards this other electrode, okay, this bimetallic strip will make in contact with other electrode. Now the circuit is closed. When the circuit is closed, current will be flowing through this path because of no spark between two electrodes. Okay, this bulb gets turned off. Because of no heat energy. That bulb gets turned off. Okay, when it gets turned off, okay, this bimetallic strip gets cooled down. Okay, cools down means, okay, gets cooled down means, okay, this bimetallic strip move away from other electrode. Okay, when it is moving from other electrode, means in this case current is flowing. Let some 3 amps current is flowing through this path. Okay, before opening switch. Here now you are opening switch, means you are changing current from 3 amps to 0 amps within some fraction of time. Okay, okay, means within 0 time you are changing voltage from one level to another level. Okay, you know V is equal to L di by dt. Okay, almost within 0 time you are changing current from one value to another value, means almost, I mean, the voltage which is produced across choke coil would be very large value, around 2000 volts or 2500 volts. Around 2500 volts will be produced across this choke coil. Okay, this 2500 volts plus 230 volts. Okay, around 3000 volts. Will be produced between two electrodes. Because of this much high voltage, an electric arc will be established between these two filaments. Okay, then current will be following this path. So tube light works. Okay, let us discuss this problem. So now, here V of t is given, I of t is given. Okay, we have to find the value of R, L, tau. Okay, so here you know, right, voltage across inductor is equal to voltage across resistance, okay, which is equal to I into R. Okay, simply VL by I gives what? R, right? VL by I gives what? R. Okay, so 80 by 5. Okay, 80 into e power minus 1000t by 5 into e power minus 1000t milliamps into 10 to the power of minus 3. This is 80 into e power minus 1000t. 1000t. Okay, which is equal to how much? 16 kilo ohms. 16 kilo ohms. Coming to the value of L. Okay, here from this is what V of 0. Okay, otherwise this is I of 0 e power minus t by tau, right? Okay, t by tau. Okay, so here 1 by tau is equal to how much? 1000. Okay, you know the value of tau is what? Tau is equal to L by R. So L by R by L is equal to, because it is 1 by tau, right? R by L is equal to 1000. Okay, from this we can find the value of L. You know the value of R. Okay, R is 16 kilo ohms. 16 kilo ohms by 1000 give 16 Henry. Okay, so 16 Henry is the value of the inductor, right? Tau is equal to what? Tau is equal to L by R. L by R, or directly you can find here T by tau is 1000. Okay, then tau is equal to 1 millisecond. Tau is equal to 1 millisecond, right? Okay, next, calculate the energy dissipated in the resistance for 0 to 5 milliseconds. We have to find energy dissipated in the resistance for 0 to 5 milliseconds, 0.5 milliseconds, right? Okay, first let us find initial energy. What is the energy at t is equal to 0? What is the energy at t is equal to 0.5 milliseconds? Okay, then we will come to know the energy dissipated in the resistance from 0 to 0.5 milliseconds. Okay, what is the initial energy? W naught is equal to, or W0. W of 0 is equal to what? Half Li square. Half L I of 0 square. I of 0 square. Okay, which is equal to half into 16 into, what is I of 0? I of 0 is, from this you're going to get I of 0, right? I of 0 is 5 into 5 square. Okay, let me use calculation. Okay, here 5 square into 10 to the power of minus 3 square, because it is in milliamps. Okay, let me use calculation. You're going to get, okay, it's just 18 to, okay, 16 by 2 is 8, right? 18 to 25. Okay, 200, right? Okay, 200 microjoules is the initial energy. Okay, now let us find energy at t is equal to 0.5 milliseconds. Okay, half Li square L. Okay, what is I? 5 into e power minus 10 to the power of 3 into 0.5. 0.5. Okay, let us find over here. W 0.5 is equal to half L. L is 16. L into, what is I square? 5 into e power minus 10 to the power of minus 3 into time t is equal to 0.5 into 10 to the power of minus 3. Okay, whole square. Okay, let me use calculator. Okay, 8 into, anyhow it is 25 into e power minus 2 into 0.5 into 4 minus sorry it is 10 to the power 3, right? Okay, so 1 by 2 into 16 into 5 into e power minus 10 by 10 power 3 10 power 3 into 0.5 10 to the power of minus 3. Okay, okay then sorry. We're going to get e power minus 2 into 0.5 into 25 into 8. Okay, yeah, you're going to get 73.575. Okay, or 576 microjoules. Okay, okay, so 200 microjoules minus 73.576 microjoules. Okay, minus 200, you're going to get 126.42 microjoules. Okay, this much energy is dissipated in the resistance for 0 less than t less than 0.5 milliseconds. Yeah. Now, let us draw equivalent circuits. Here, this is element. Equivalent circuit. Equivalent circuit. Equivalent circuit at T is equal to 0 plus. Equivalent circuit at T is equal to 0 plus. Let us take resistor. Okay, resistor. R is the resistance of this resistor. What will be the equivalent circuit at T is equal to 0 plus? Okay, resistance only. This is an equivalent circuit. Okay. This resistor is behavior of this resistor is independent of time. Coming to inductance, inductor L. Okay. Inductor acts as open circuit. See here, with zero initial value, with zero initial value. Means I of 0 minus is equal to 0. I of 0 minus is 0. Okay. Current to the inductor cannot change instantaneously. I of 0 minus is equal to I of 0 plus is equal to 0. Okay, with zero initial condition. With zero initial conditions, okay, what is the equivalent circuit of inductor? Okay, it acts as open circuit. Okay, inductor acts as open circuit. At t is equal to 0 plus. At t is equal to 0 plus. This is the equivalent circuit of this inductor because it is acting as open circuit. Because I of 0 is equal to 0. Current is 0. Zero initial condition. Okay. Coming to capacitor. Capacitor acts as short circuit with zero initial condition because VC of 0 minus, if VC of 0 minus is 0, okay, VC of 0 minus is 0 with zero initial condition. Okay, if it is uncharged capacitor, then VC of 0 minus is 0. Then VC of 0 plus would be 0. VC of 0 plus would be 0. Okay, if voltage across capacitor is 0 means it acts as short circuit. Inductor with some initial value. Let I naught is some initial value. Inductor with initial value I naught. Okay, then this will be the equivalent circuit. That can be replaced by inductor can be replaced by current source. Now it is acting as current source. If t is equal to 0 plus, if t is equal to 0 plus, it acts as current source. It acts as current source. Okay. Now capacitor with initial voltage. Let V naught is voltage across capacitor, initial value. Okay, then the equivalent circuit will be this voltage source V naught. Capacitor is replaced by voltage source. This is the equivalent circuit to the capacitor. Okay. Here I of 0 minus is equal to without zero initial. Okay. I of 0 plus is equal to I naught here. Here V of 0 minus is equal to V of 0 plus V of 0 plus is equal to V naught with initial condition. With initial condition. Okay. Now element equivalent circuit at t is equal to infinity. Equivalent circuit equivalent circuit at t is equal to infinity and time of the. Okay, you take resistor first, which is independent of time. Okay, resistance only. This is the equivalent circuit. Okay, you take inductor. Inductor acts as short circuit under steady state DC current. Okay, so it acts as short circuit. Next, capacitor. Capacitor under steady state DC voltage, capacitor acts as open circuit. So open circuit. Open circuit. Okay. Inductor with initial value. So let I naught is initial value in the inductor. Okay, then you're going to have the circuit like this. Short circuit because of initial value current source. Okay. This is the equivalent circuit. This is the equivalent circuit. Okay. This is the equivalent circuit. This is I naught. Voltage, sorry, capacitor. Capacitor with initial value V naught. Then the equivalent circuit will be V naught and open. Let us wind up this session.